Awesome. So good evening, everyone. I'm so glad that you could all join us for Humanitarian Engineering's second Gold Nuggets interview of the semester. I'm Nina Gazzetti. I'm a sophomore in Geological Engineering, and I will be co-hosting this interview with Jules Brown, a senior in Mechanical Engineering. And we have the pleasure of interviewing Dr. Santi of the Geology and Geological Engineering Department tonight. We are excited to explore his background in the geotechnical field, as well as his current research projects, and hope to facilitate a discussion about humanitarian engineering values within his field of expertise. And if you have any questions that you would like asked or want to ask, just like feel free to put it in the chat or like private chat myself, and we will make sure that they will be asked. And again, thank you for being here tonight, Dr. Santi. And to start us off, could you just describe your journey to where you are today?
Sure. Yeah, so I was always, well, thanks for having me, first of all. It's a good way to end the day. But I was always sort of math, science interested. And my father was a civil engineer, so of course I couldn't be a civil engineer. I had to find something else to do. But I'd say my real interest came from just being outside all the time. I was a Boy Scout. I worked at this summer camp for 5 years, which was like 10 or 12 weeks of summer. I mean, the day after school ended, I was gone, and I didn't come back till 2 days before it started. And so basically I've tried to recreate working at Boy Scout camp in my career. And
That's great.
I think I've come pretty close. There was one year the students gave out, the seniors give out awards to students, and they had like quotes, and apparently I said, this class is going to be just like Boy Scout camp, except without the wedgies. And I do not remember saying that. So, I think those combined in definitely, I knew I needed to do something along those lines. And so when I got to college, I started majoring in physics, and within a couple semesters realized that's not what I wanted to do with my life. I liked geology, but I had enough physics classes that with a couple more, I could do a double major. And so I'm a great example of somebody who slides through with B pluses or worse in some cases, doesn't understand the subject at all, but has it on his diploma. But geology, I understand. And then, I'd say I liked the applied aspects of geology. And it wasn't enough for me to pick up a rock and say, oh, it's a granite. I was always asking, well, so what? Why is that important? Why does it matter? And so I just got more and more onto the applied side. So I went from geology to engineering geology for my master's. And then in the workplace, I worked for 6 years in industry, and then came back and got a Ph.D. here in geological engineering. So I'm just moving farther and farther onto the engineering side as life goes on. So long answer for that question.
Yeah, so what is the most impactful work that you've done as a geotechnical engineer?
I'd say if I'm thinking about what's going to last and what is a legacy, it's clearly the teaching and the students. And I can spend a long time writing a paper, and if it's really good, there might be 30 people that reference it, 40 people over a career. But I teach 40 students a semester, and so that the teaching's really important. But as far as the research, I like what Kamini Singha says, that we want our research to be kind of world changing, but in reality, we are adding to the conversation. And so we want to write things that are going to make a difference, but most things add to the conversation. I do think I've had a couple projects and things that have made a difference. And I'd say those are the humanitarian ones, really, that, the science affects such small people or such small groups of people. And so had a paper on looking at debris flows, which I had studied for years, these mudslides that happen after rain events. And we did an overview paper on fatalities, and it was worldwide. We looked at a 60-year period. Where are they happening? How is it related to things like literacy rate and healthcare systems and ability to respond to natural hazards? And that's been a really popular paper. We did another one really it had two aims, and one was for scientists to understand a lot of the elements that social scientists will bring to the conversation when you're trying to do mitigation for something like debris flows. And then we were also writing it for the social scientists to give them a resource to use for mitigation and say, look, here's in sort of plain English how these methods are done and how you will match them for different situations for people. And that's been a popular paper. And then I think the work that Ethan's here on the conversation, the work that he and David Laporte did in Guatemala City, looking at landslide hazards and how to get that information to the community and help them, really empower them to do something that was useful, that was within their sort of economic means, and it worked well with that community. So I know I'm preaching to the audience here, but realistically, the humanitarian tinted research is the stuff that I think is going to last and have more impact.
Yeah, absolutely. That stuff sounds like really fascinating. And I guess you touched a lot, you mentioned like education also, and then just like this whole like scope of humanitarian engineering being your most impactful work. Like maybe what event stands out in your experience, or like what called to you? Like when you said, okay, like the most impactful work I did was humanitarian engineering work. I mean, you talked about your journey. You did physics and geology. It's pretty technical work. What kind of inspired you to like look more into the more human-centered side of that field?
You know, it's interesting. Right before I taught at another university, and right before I came back to mines, we had lived in Denver when I got my PhD, and I had a friend that sent me basically the front page of the Denver Post, and it was an article about the Redfield Rifle Scope plant, which was it was in Southeast Denver. They basically made rifle scopes, and they used TCE. Anytime you have a lot of optics or a lot of metals that need to be clean, TCE is the sort of the substance of preference. And this stuff had been leaking into the groundwater, and it hit an abandoned channel of Cherry Creek that's more or less parallel to Cherry Creek, probably 30 yards wide, and it traveled for miles. And it went right under my old house that we had lived in and sold. And at that point, I had worked in the environmental industry for years. I had taught groundwater for years. And overnight, my perspective changed, because suddenly now I'm on the other side of the fence. And instead of trying to sort of antiseptically look at the problem and say, oh, here's where the water's going, and here's the concentrations, and we can do calculations for inhalation rates indoor and relate that to cancer rates and everything. Now all of a sudden I'm thinking, I had a baby that was crawling on the floor for 6 months in this house before we moved. And it was a totally different perspective, and it really kind of opened my eyes to things. And so, if there's a way to be able to get that perspective without having to put yourself at risk for all the TCE related illnesses.
I think that's a really great perspective. That, like you touched on, that like being able to change your vantage point is super important. So following that, could you share a particular event that stands out as an experience you never thought that you would have as an engineer?
Yeah, I got to fly a B-52 simulator.
Wow.
I'd spent about a month, 6 weeks altogether on the island of Guam, doing geological mapping and planning investigations for a housing development that's going to be built. And we were scuba diving every spare moment that we had. And we met a guy diving who was a civilian contractor that ran the simulator. And at the time they were shutting down Anderson Air Force Base. And he said, oh, just come by some night and I'll let you in to fly the simulator. And so we went into probably, it was probably $10,000 worth of government time on this machine. But it's, it's just what are these things? And from an engineering standpoint, of course, it's fascinating to see how the thing works, and how you actually cannot do a simulated loop, which he told us that his roommate could do on the simulator. And we tried, and we shook the guts out of the machine, and crashed it basically.
That's awesome. Oh my gosh, would not have expected that to be the answer to that question. Um, so then I guess just to round out your background experience, like what really called you to become a geotechnical engineer? Were there any like key moments that inspired you? When were you just like, okay, I don't really like physics, I want to do geology?
Yeah, I took a class. It was I'd taken a field trip class in the fall with a professor whose name is Orrin Pilkey. And a lot of people know him because of his work in coastal areas. And he's been sort of the voice of reason for 5 decades about not building on the beach because it's a dynamic environment. And so then I took a spring break class with him, and we drove the entire Outer Banks of North Carolina and would sneak under houses and look at the construction. And then we'd leave because he said, last year they called the sheriff on us. And so we're zipping along, and it was just totally using geological principles to understand engineering things, and to look at hazards and how we can use this sort of wisdom to help people do better when they're building communities. And that it doesn't matter if it's a rich beach community in North Carolina or whether it's a poor settlement on the sides of Guatemala City that they're on the slopes. And so that really changed my sort of my focus and my direction when I realized you could do that with your geological knowledge.
Yeah, that's great. Sorry. Our next question is do you think your work pertains to the public? Like, how does your work with geotechnical engineering and risk assessment coincide with public interests?
Oh, absolutely. This is the classic engineer role that you have a duty to protect the public, and the case study that people refer to is the space shuttle and the O-ring problem. The guy who was the whistleblower on that just died a couple weeks ago, and he did the right thing. He saw this was a problem, and he went up the chain and tried to be vocal about it and get the word out there, and it sort of got muffled. But as engineers, that's we can't just go around saying the sky is falling all the time, but we do need to be people who are looking out for the interests of the public and figuring out how to communicate that. And part of that, for what we do is, we're like, as a geological engineer, I'm usually called in to solve problems. Problems that could have been prevented if I'd been involved earlier and they listened to me or whatever. But there are often other things that are the interests for, if somebody's building a condo, they're going to put it where the land is and then come back and say, you're an engineer, figure out how to solve these problems. And so we're always waving our hands and saying, well, you shouldn't have built there in the first place. But in reality, we're not usually involved at that part of the decision. And so we come in and we've got our job is to figure out how to help them find solutions. And again, I think that's just a great approach on the humanitarian side, because you're coming in with problems that are there. And you say, okay, what's realistic and a way to protect people, to protect the environment, to protect resources.
Right. And you said at the beginning of that, I mean, we asked, like, do you think your work pertains to the public? And you said absolutely yes. Do you think that most people in this field think that way? Or maybe do they know that it pertains to the public, but they don't really feel obligated to the public? What is your perspective on that?
I think people do. I think people do. Engineers are a very practical, pretty responsible bunch for the most part. I think maybe it unintentionally might get forgotten, or I'm very goal oriented, and I want to move along here and get this thing done, and I'm thinking about finishing, and sometimes I might not stop mid-course and say, oh, is this the right direction? But certainly at the beginning, and certainly if you ask people, I really think that there's a responsibility level there.
That's good to hear, since that might be my future field anyways. So, um, So which aspects of geotechnical engineering are human-centered and why?
Well, for you're saying geotechnical engineering. I want to clarify geological, because
Yes,
geotechnical is
sorry.
more about
Geological engineering.
civil engineering. That I'd say it covers a slightly different area than we do, but certainly things related to hazards, geological hazards. And so that's been my research, is rockfall and debris flows and landslides and a little bit of earthquake stuff. So that's huge. And then, I would say just this idea of design constraints. We're not just designing to control the process that's causing the hazard. There are economic issues, and there are community issues, and maybe the land has got other significance that we have to account for. We're trying to keep water supply clean during construction. So I would say hazards, and then the sort of design constraints, because it's part of a community.
I think that that you touching on how important the hazards are and how they affect the community is a really interesting point. Building off of that, how do you balance all of the aspects of like this risk assessment in your work?
Yeah, so a good example of that, a while back, CDOT came to us and asked us to revise their rockfall hazard rating system. And so, there are a million rockfall slopes that can be dumping rock onto highways in the state, and they're responsible for all of them. And they've narrowed them down to 750 sections that they're worried about. And so they want to know which we can't, with an infinite supply of money, we could not fix all of these 750. So how do we prioritize those? And so that's the rockfall hazard rating system, is we're going in and we're saying which ones are most likely to come down. They're going to be the biggest, that are most likely to impact the most traffic. And so the system then helps them prioritize and say, okay, here's the top 10. Those are the ones we're going to worry about this year. Next year, we'll worry about the next 10. And people are going to get hurt on the ones that are, number 300 on there, but they cannot physically stabilize all of this. And so, I think from a risk standpoint, helping people have a transparent and sort of defensible way to prioritize their limited budget. And it's something you got to be comfortable with as an engineer. You want to fix it all and you want to protect everybody, but rockfall's a perfect example. You drive through Glenwood Canyon and there are literally 10 million rocks that could come down and actually hit that highway. Which one's going to come down next? That's the question.
Right, yeah, and that really goes into the next question we were going to ask. I mean, your background includes a lot of like expert opinion on flow hazards and rockfall and whatnot. So like accommodating the wants of clients and then maybe the risks posed to both the clients and the public seem maybe contradictory or like conflicting in some ways. How do you like balance that conflict of like, okay, well, I want to help everybody, but the client only wants this one thing?
And that's really tough, because it's like being a lawyer, right? You're being paid to represent someone's interests, but you have professional boundaries to how far you can go. And so the way I get around it, or the way I start those type of projects, is usually they call and they tell you a little about the situation, and I ask who else is involved. I want to know, am I picking a losing side here? and then if I feel comfortable that they're on the level on this whole thing, I say, well, send me the reports. I will look at some things and I will tell you what I think. Then you can decide if you want to hire me or not. In that way, it's, then later down the road, if I'm being deposed or something, I can make it clear I'm either not just buying, putting words in my mouth and buying an opinion, that I've come to them and I said, here's what I think. And you may not like all of it, but this is professionally, this is what I say. And so that's been really freeing. And then accommodate the needs and wants of clients. So you know, one thing I've done a lot with the undergraduate design class is on one of their projects, it's a site that I actually worked on in industry, and I'll talk about some later on probably, but it was there was a contaminant plume in groundwater. There was a regional water quality control board. There was a community. There was the owner. You're working for a consulting firm. There's all these competing interests. And so I would have the students then do an analysis and figure out what's going on in groundwater and how it could be fixed. So everybody has the same data. And then I divide them into teams and say, okay, your team is representing the city, and you've had a water well that's been ruined because of this contamination. And here's what you want out of this particular public meeting. And this other team represents the owner, and here's what you want out of this meeting. And so basically then everyone comes together and they all have the same information. They can't lie or trick anybody because everybody's professional and understands the concepts. And so it's this idea of representing an interest. You may not agree with 100%, but you're obligated to represent the client's interest, but you're bound by your sort of professional duty and to be straightforward and to not shade the truth or anything like that. And then we, at the end of the meeting, then, and we run it like a public meeting. Usually there's a grad student that's sort of has the gavel. And at the end, we drop these advocacies and have them come back and say, well, how did that feel? And what went on in your mind with that? And so to me, that's the kind of experience that I felt took me years to sort of go through and recognize what that felt like. And then there are times there are just clients who just won't represent, or you say, look, I disagree with you. I was telling students today in the landslides class, there was I had a phone call years ago from someone who had a property that had a mapped landslide on it and wanted to build. And he said, oh, this person, Karen Berry, said that I shouldn't build there. And it's like, I'm not going to represent this guy. I said, look, if there's anybody in the world who would know that, it's Karen Berry, because she worked on the landslide right down the street and told the county not to let them build. And the developer finally allowed them to build, and they ended up having to abandon these 3 houses. And she's the state geologist now. So, you know, I wasn't trying to be snarky or bitter with him, but it's like, I can see where this is going. And I'm not going to represent someone to argue that they should be allowed to build in this particular location.
Yeah. And do you ever feel, I remember it was a CERC meeting last year, and I think Ethan touched on this. He was like, they'll get proposals or like, you know, like leads on work, right? And sometimes they'll feel pressured. It's like, okay, if somebody else doesn't do this, they're going to do a bad job, or like it's not going to be safe. And kind of feel conflicted because maybe it's not something that they would normally represent, but they feel pressure themselves because they're more responsible to pursue that lead of work. Have you ever encountered that in your experience?
When I worked in industry, we went in a number of times and had to fix problems created by other people. And you can kind of see this, that, oh, we had this report, and then a year later we had this report, and here's what we did, and there's a problem. And they're just kind of working their way to the better companies that they should have hired in the first place. So yeah, and you know, Ethan's company they're just fantastic about handling the human side of this, and they've got a great reputation in that sense. And so I have not really encountered companies that approach it from that sort of responsibility, saying, we'll take this over because it's risky enough that the world needs us to do it, rather than someone that might do it more cheaply or inappropriately. So how's that for a non-answer?
It's something.
So next, could you tell us a little more about your current research project about landslide risk perception and risk mitigation?
Okay. So I've had some older projects related to that. We're doing things along similar lines in Peru right now. and it's not just landslides, but we're going into communities and mapping all the hazards that are there. And then we have a social science team who is interviewing people, walking around and doing sort of this citizen-based mapping and getting information from them. And then we're really trying to get a sense from the risk reduction side of what sort of mitigation will make sense for them. And so part of it's economic, what can they afford? And I think part of it is regional. So for instance, in this area, they're very used to spring floods. The melting snow up in the Andes comes through, and even though these towns are in the desert, they've got 6 feet of water filling the valley. And so they're very used to dealing with that. And they've been building these flood control dikes that are really simple. It's just you get bulldozers and you line up all the gravel and rocks and everything into these long sort of levees to keep the river in there. And so when we're talking about dealing with a different hazard like debris flows that don't occur every year, that are coming out of the side canyons that normally don't have water in them, these building levees is a great solution because they can see the comparison, and they can see how it's a very similar process. It's a slightly different material. They know how to control it. They've got the resources to do it. From an engineering standpoint, they kind of know what works and what doesn't work. Doesn't require real expensive design. And so that's been a really helpful approach. And then just things like warning systems and helping people recognize what areas are dangerous. Safe places to go are huge for hazards. There's a classic story, was I think it was in Colombia. There was a debris flow. There was an earthquake that occurred, and people knew that there were some problems related to that and there might be flooding, and they all went to the church because that was sort of this rally point, this meeting point. And so pretty much the whole community was there, and then this debris flow came down a few minutes later and basically killed most of them because they had rallied in the wrong place for this particular sort of hazard. If it's an earthquake and that's all there is, it's fine. But so just having some of these things to help people go the right direction, make sure they're aware of the hazard. When do they need to worry about it? How much rain would cause this sort of event? That sort of thing. I'll stop there.
Yeah, so you mentioned, right as you were defining this research in Peru, you said that there was social science teams going around and doing community mapping. Is that normal in a lot of projects that you've done or research, or is that like kind of novel?
I think that's pretty novel. Most of the industry work I did was in the US or US territories. I think there's certainly an effort to engage the community and interact with them. But as far as sharing information and involving people, walking in the field and pointing and talking about things, I think that's not quite as common. It's important to do. It's important to do, and not just to engage the community, because of the history. So one of our social scientists is writing a paper on this very topic, and how to interact with the two of them. And one of the things we put together in this paper is sort of for different aspects of hazards, which components are the scientists kind of better at, and which components are the community members better at. And so for one example, the historical part of it is much better for the community. I can come in as a scientist and I can say, well, this is an active process, and maybe I do some age dating, and so I know it happened 3 times in the last 10,000 years, but I don't know that it happened 5 years ago and 25 years ago and 55 years ago. And that's the important information that the community can provide. And so having this sort of historical picture and recognizing which elements of your job you're going to get the best information for is really going to help you a lot.
Right. Yeah, and then especially, yeah, I mean, I feel like it is pretty novel taking community knowledge, local knowledge, and applying that to technical projects. And you said, I mean, going back to the whole like social science team, you work with them, right? The engineers work with the social science team, or are they kind of divided? Or do you guys come together at the end of the day and kind of combine both of your brains?
Well, so for this particular project, they were working separately from us. I mean, they were in the field with us originally, but then when they came back and did that work, just timing wise, we couldn't go with them. But we're already planning for the next phase, which hopefully will happen this summer. There'll be certain days we'll spend together, and then we'll split into teams and try to have a physical scientist there with the social science team. And that's ideal.
Great. So kind of moving towards a different topic, but like still the same sort of thing. In your opinion, and like from your experience as an engineer, how are engineers accountable to the public?
Well, there's certainly a professionalism that we carry with us as licensed professionals. There's I don't think it's active at mines, but there's a group called the Order of the Engineer that it's more Canadian maybe, that there was a failure. I don't remember the details, but a building collapsed or something. And theoretically, they've taken metal from this building and made rings out of it. And so you'll see every now and then an engineer will have a silver pinky ring. And that's sort of a reminder of the public trust. And so professionalism is part of that. I think this upholding the public trust is important. And then really the accountability, I think, is a standard of practice. And if you're going to court about something, that's often the issue that's brought up is, did this engineer do what they were supposed to do based on the standard of practice at the time? And it recognizes, you could have spent 10 years studying this thing and doing an extremely robust design that's really expensive and made it bulletproof. But it recognizes that's not always realistic. What is the standard of practice for this particular job at this time? And then keeping an awareness of how that changes. So in 1989, the Loma Prieta earthquake in San Francisco, I lived there at the time, and it collapsed the Cypress structure, which is this double-decker freeway, and that's where most of the fatalities were. And basically the way it was designed, there were a couple issues with the geology, but one from an engineering standpoint, it had the columns, and then the decks were kind of spread between these two columns. And basically the way it shook, there wasn't enough steel in the columns, and they ruptured, and then everything fell down. And so it was built to 1950s industry standard of practice. But more recently, the standard of practice would be to include rebar in the columns that was torsional, that was moving in a different pattern. They'd actually scheduled some of these to go back and retrofit them, but they hadn't gotten to it yet. And so, it was designed to an original standard of practice. It didn't meet the current ones. And when you hear about these grades of the civil engineering infrastructure of the US and how so many bridges don't, they're decaying, they don't meet recent standards, those are engineers that are saying, that we're losing the public trust because we know now that these are not as stable as they need to be. And we've got to make that a priority. And so, my hat's off to them. It's a big battle, and trying to get the money to fix these is really difficult.
Yeah, that's interesting. I've never thought of it that way, kind of how standards of practice have evolved over time or clearly changed because of events like an earthquake, collapsing two double-decker bridges.
Mm-hmm. Mm-hmm.
So, and kind of like switching gears now, do you think like that all like concerns of like the public, like all concerns should be treated equally? Like maybe, like an earthquake is going to happen, but maybe it's going to cost so much money to mitigate for that or like to build for that. like how do you balance the concerns of everything equally or in like an equitable way?
It's hard to do. As for what I do with hazards, we do a lot of ranking and prioritization. And so, from our standpoint, what's the most risky, what's the most dangerous, and so on. But you can't always go with a majority opinion. So if you went into a community and said, should we clean up the water supply, or should we stabilize this landslide, or should we deal with the crime? People have different opinions, and if you took a vote, there might be an overwhelming majority, but there's got to be ways that you can include the minority voice. And so these are hard questions, and I'd say there's got to be some compromise, and there's got to be a willingness to engage all these groups, and then help work out a way to say, okay, what are we going to do first? And is it going to be based on the danger? Is it going to be based on which one is going to improve lives for the most people at that time? I don't know the answer to that. And realistically, I think a lot of that comes from the community and people who are maybe not engineers. we tend to be more of the problem solvers rather than the ones who prioritize the problem. And I don't want to just shove it off, because, like I said, from a hazard standpoint, we're always prioritizing, which problem is more important than others.
Yeah.
When you guys get later in your career and you know the answer to this, come back and tell me.
I'm not sure we ever will. I don't know.
Kind of building off of that train of thought, how might social justice or cultural constraints play into engineering accountability and responsibility? And how might the culture of engineering as a field take away from the responsibility of the individual engineer?
Okay. Yeah, so social justice and cultural constraints, that's a lot of what we wrote about in the paper I referred to at the beginning on dealing with debris flow hazards. And we have 3 examples in there. One is Southern California, one is in Guatemala on Lake Atitlan, a debris flow issue. And then the third one is in Pakistan, part of the Himalayas, where one of our authors had worked a lot. And just looking at the different approaches and what made sense for people. And there are a lot of issues that have to be considered. And so, in the US, it tends to be a little bit more sort of economics and, expediency and things like that. And when you move into places that have much more historical ties to the land, one that really struck me was that, I can look somewhere and say, well, you shouldn't be living here because it's a landslide. But someone might say, well, we've been here for 20 generations, and this land is part of my culture, and it's more, I'm giving up more than just living around the corner that's somewhere safer. And so, even if someone has the opportunity to move, it's hard to really force someone to do it. And then there are just different approaches. Like a huge one is this idea of just sort of giving up on things and saying, well, the landslide comes down and hurts us, it's God's will. And we look at that and go, oh, we're scientists and we can do this and we can predict it and everything. And this is an ignorant approach, or it's not taking into account science, or for whatever reason. I'm a religious person, and I wouldn't go that direction. But in reality, a lot of these are just coping mechanisms, and so it's someone saying, I want to protect my family. I love my kids just as much as you do. I just don't have the resources to do anything else. And so mentally, this coping mechanism is saying, well, it's fate. Whatever happens, happens. And so it's not someone ignoring the science. It's someone saying, it is not in my power to do what you're telling me I need to do. And I think things like that and being able to recognize those sorts of things is, wow, that would make you a much better engineer.
Yeah, that's an interesting point, like the acceptance of risk, just as fate. That's yeah, that must be kind of tough to hear as an engineer, but also I guess inevitable if people think that way. You can't change the way people think, right? Yeah. So I guess and switching gears now, um, have you ever been in a situation where you had to like manage multiple and perhaps like competing stakeholders or communities?
Yeah, so I gave you an example of that Fort Ord where we held the public meeting. Um, Another one was in 2014. There was a landslide in Washington State called the Oso landslide, and it basically there was a community that had been built at the bottom of this, sort of against the scientific advice over the last 30, 40 years. 43 people were killed in this landslide. So it's a huge deal, and they have and basically they were tying up every landslide expert in the country was being sort of absorbed by one side or another, because there were a lot of competing interests. And so I got called on one of these, and it really had to do with a very small log wall that was built near the toe of the landslide, um, basically by one of the Native American tribes in the area, because the erosion coming off the toe of this ancient landslide was sort of fouling the stream and affecting the salmon population. And so they used like giant telephone pole sized logs, and they built a pretty tiny retaining wall just to slow down the erosion. And it worked, and the salmon came back and everything. And so part of the issue was, how much did this contribute to the landslide? And you look at it, it's this little wall right here in the landslide. It's this gigantic thing. And just from a sort of logic standpoint, you kind of know what the story is. But it just struck me how I'm reading these reports on this landslide, and it's like, okay, here's one that was the county had put together, and there's 12 professionals, all landslide people, and I know half of them. And then here's another report that says the opposite, and it was hired by a homeowners group, and it's again 12 professionals, I know half of them. And so reading through all of those and seeing how people had different opinions when looking at the same data, and people whose opinions I trust and I think are really on the level for most of these, not all of them. But it was just kind of a weird story, because it felt like the circles were moving out, and I could see, the report that came out that summer was this National Science Foundation panel that had gone out there, and it's all the big local names with a couple others thrown in. And then the report that came out a year later was slightly bigger circle, and they went into California to find landslide professionals. And then 3 years later, here am I coming in, and the radius now has gotten out to Colorado. And it's like no one wants any surprises, because there's so much money involved. So they all want to tie up these professionals and say, okay, you have commented on this thing, whether you liked it or not. That means the other side cannot hire you to say the opposite thing.
That's a really great perspective. And just like an example on the whole thing. So kind of a different segue now. How would you define a good engineer from your field of expertise? And like, what are some examples that you might have seen of a good engineer? Or good engineering, all encompassing.
I think I'm going to take a different angle than a lot of people would. And that is, we think of engineering as like we do in school. And the closer I can get to the right answer, the better I am. And you spend your entire education trying to get close to the right answer. 98's a pretty darn good exam, and all that. And then you go into industry and practice, and you have to get 100 every time. The right answer is expected. You're not going to get the calculation wrong. It's inconceivable. If you get it wrong, you're a terrible person. And there are all these safeguards put in companies, and somebody's reviewing your work, and there's all this back and forth. And so we have to get out of the mindset that I'm trying to get close to the right answer. So in the background, it's a given that you will have the right answer. But what makes you a good engineer is how well you present it, how well you communicate it. Okay, you can do the calculation, you can take the data and say, this O-ring doesn't behave properly when the temperature drops below 40 degrees. Okay, but how well do you get that information up the chain of command and basically not shut down the communication because everybody thinks you're alarmist because you've been, crying wolf, on anything that you don't like. So there's just a lot to relating to the people around you and relating to the community and communicating it. And so I would argue that a good engineer is somebody who can really clearly get the point across and maintain open lines of communication. And I want to move beyond saying a good engineer is the person who can do a slightly more complicated calculation than everybody else can.
That's really interesting how you mention like in the professional field, right? You need 100% every time, and I think that just comments on engineering as a whole. Like we're really solution oriented. Like there's one numerical answer. Like that's mostly what we learn in undergrad, right? And clearly, there's not even like really a right answer when you get into like the professional field because there's, like you said, so many things you have to balance. So like really work isn't straightforward, and yeah, that's a really interesting perspective. I like that. Good engineering.
That's a great point. And I should not have implied in my answer that we're getting towards one answer, that there are multiple possible solutions, I guess. And I'd say, and there are multiple viable solutions, but I'd say that the good engineer is the one who can communicate the options the best, which solution offers something different from the other ones, to help the client in their decision on choosing one of those.
Right. So then like going off of that, how do you think like you or like minds can like best prepare future engineers and scientists to think about the public accountabilities or like maybe the right answer to their work beyond just the technical side?
I'll tell you another experience I had. So there were several of us at Mines that worked on a consulting project for Grand County and the city of Granby. They had they were trying to close their landfill a number of years back. And unfortunately, they had built the landfill on a landslide. And so there was a very wet winter, and like they officially closed the landfill, but they need to get the state to sign off. And basically this thing is sliding, and you could look down and see trash under all the soil and everything because there were gaps opening up, and they could not get in there to fix them because it was this wet, muddy winter. And so this poor county that's not very big, 15,000 people, has got this really expensive problem that they're trying to deal with. And so they had hired a number of us and a couple consulting firms to say, look, how do we manage this? How do we close this landfill? And so we were dealing with more the landslide stabilization side. And to get an answer as to what mitigation might work, we had to do all sorts of drilling, investigation, and all this stuff that's hard to do on a moving landslide, and it's super expensive. And so I thought, the responsible approach was that we did a phased investigation. We had this really clear flow chart. And we said, okay, phase one, we're going to do, I don't remember, but these 3 borings, here's where they're located, here's the depth. And based on what those show us, we will either move this direction or this direction. And that would take us into phase 2 and whether or not we spend more money on more investigation. And we would keep going along, and phase 3 would eventually get you the information you need to design a groundwater extraction system or retaining wall or something like that. And so phase 1 was not super expensive, phase 2 was pretty expensive, and phase 3 would be very expensive. And we got through phase 2, and at the end of that we said, you know what, we know enough now to say we shouldn't go to phase 3, and that this particular thing is not a viable option. And you felt terrible, spending money for this county. A few years before, this was the county that a guy disgruntled worker had armor plated a bulldozer, and basically demolished the library and some city buildings. And so they're still reeling from that. They're talking about selling the courthouse and renting it back so that they would have enough money to pay to stabilize this landslide. And so we were all just feeling like super responsible for these folks that we wanted to do this. And so anyway, where I'm going with this, we had this phase investigation, and basically we had to digest this for the county commissioners, which is this group of businessmen, ranchers, people who are not necessarily scientists. And we've got to give them the information they need for decision points. And so they were like, well, what's the chance of success of this? So we would say 25 to 50. This is our judgment. We didn't have solid numbers, but they needed something to make a decision. And so it was all about how do you kind of handle this, these competing interests.
So we all know that, especially in engineering fields, we often have to choose between cost and safety. So with this in mind, what recommendations would you have for future engineers?
I don't think you can sacrifice safety. I think cost might drive whether or not the project goes on. Again, you don't want the reputation as an alarmist, somebody who's always saying no, because that's unproductive. In fact, I used to joke when I was in industry that engineers never get along with lawyers or accountants, because lawyers and accountants are trained by nature to be no people, to say, no, we can't do it. We've got our set of rules, it's protecting everything. Here's what's going to come back to bite us, and we can't do this. Engineers, by our training, are yes people. We're trained to say, oh, okay, well, let's figure out how to get this done. It's not working the way we expected. Let's figure out another solution. And so we're always at odds with those sort of people. And so I think and I make a joke about it, but just recognizing that helps a lot, because the engineers and the accountants, the lawyers and the accountants have a role in the company, and that is to warn us about things and to follow procedures that are going to protect us from whatever future lawsuits or anything. And engineers have a role to solve problems that come up. And we're not ignoring these rules that they have, but we look at something and say, oh, okay, I think there's another way we can do this. And that's not their training. And so to me, that's kind of this cost safety argument, is we look at that and say, I'm not going to sacrifice safety. I know that cost is an issue. My job is to figure out a way to get those two to work together.
Yeah.
And so, I can give you an example just on, a couple other projects I worked on. They're both rockfall problems, and it was a matter of timing. It was the owner was interested in the safety. They had the money to deal with this, but they were in no rush to spend it. And so I worked on Telegraph Hill in San Francisco. If you've been there, Coit Tower is at the top of Telegraph Hill. And on one side of it had been a quarry 100 years earlier. And so it's a very, very steep rock slope. And now there was a building at the bottom. Levi's World Headquarters was across the street. There are houses at the top. And actually the building they built at the bottom had all this reinforced concrete several stories high, because every now and then a rock would come down and bang into the building. And so my joke was, the copy guy that works in the basement corner, every now and then there's this big rumble, and he's like, what the heck was that? And it's a rock outside. So they finally hired us to say, what should we do about this rockfall problem? And so I went out and did all the measurements and the mapping, and we had different zones. We said, okay, here are your problem areas. You need to stabilize these. And like, great. And they took the report and they did nothing. And about a year later, a big massive rock came down and undermined one of these houses, and they had to eventually abandon the house. Central City Parkway, going off of I-70, up to Central City. It was built by private dollars very quickly. They did a pretty good job with it, but they had hired a geological engineer to look at rock slope stability. And there was one particular area that their company said, you need to worry about this area. And as you're drawing down the slope to make a cut for the road, you need to stabilize this. And they cut the thing down and hadn't really stabilized it. And finally they said, okay, now it's time to stabilize this. And so they brought in a $1 million crane that was going to put in the rock bolts to stabilize this. And they parked it there on Friday. And Saturday morning, a massive rock came down and crushed the crane. And then there was sort of this lawsuit from the crane company. It was like, well, your rock came down and demolished this. And it's like, well, wait a second, this is the rock we hired you to stabilize. And the timing was terrible, of course. But so anyway, the upshot was they sold the crane to some company in Mexico for $500,000 to, I guess they were going to salvage it or something. But it was a matter of they were worried about the stability. They had the safety. They had the money to pay for this, but they weren't doing it at the right timing. And so my long answer to this question is I don't think it's a yes/no answer on those things. I think they can both be done, and there are other factors that enter into this, and the communication of how soon something needs to be done is important.
Absolutely. That was a great question to a very difficult answer, or a great answer to a very difficult question, rather. So that was all that we had for questions. I know that Marie has a question she'd like to ask you. So Marie, go right ahead.
I knew she was going to ask one.
Yeah, I have two of them, but I'll start with the one that I'm really interested in, because a big portion of my work is thinking about how religious values impact humanitarian engineering and sciences. So as you mentioned really clearly, and I've seen this as well myself, and maybe Ethan can chime in with his experience, this articulation of religious belief in replace for some reinterpretation, like as you really clearly articulated, you said that they often articulate fate or belief in God as like something that they cannot control or have agency over.
Mm-hmm.
In the field, I've actually seen it the opposite way as well, in which the people give thanks often, the community members are giving thanks for the ways in which engineers are intervening in religious terms, right? And so I wonder if you've experienced that, and advice you would give to engineers or lessons you've learned from engineers to maybe not get too caught up in the power that also gives to engineers, that they can manipulate fate in some ways, which is, I think, like a really powerful place to be. And like, what would you say to engineers that are like engaging or influencing that dynamic?
I guess I would say you need humility on about 3 levels. Not accepting that you are God.
Right.
I think another is in the surety of your answer. So we go through and we calculate things and we look at options and we come back, and I think we need to make it clear all along the line that this is, there are no guarantees, that we're doing our best here, and that that there are other things that can still happen, and it's not just a liability prevention sort of CYA statement. This is more of a I'd say a true acceptance of the fact that we don't know everything, and that we're doing the best answer. We're getting the best answer with the data that we have. And I would like to think that geological engineers find that easier, because we deal with more ambiguous materials. We can't usually see what we're working with. There's a lot more variability and unpredictability. And as I tell the students, if you want predictability, go be a structural engineer, or you can use the steel manual from 1908 that has these really narrow tolerances on what the answer is. And I mean, that's facetious, but there's, I'll see this with students. The geologists are very comfortable with ambiguity. Geological engineers want to narrow it down some, and and the ones that's not enough, when they go to grad school, they'll move to civil engineering or to, something where it's a little more tightly defined. And so I think just recognizing the sources of error and the fact that we're doing the best answer we can with limited data and conveying that message.
Yeah, I'd love to say something as well that I've noticed that I've had an observation from Juan and everyone else teaching. Engineers are not just problem solvers, but they need to be problem definers. And I found that geological engineers are also versed or trained, and that we don't even know what the problem is yet. All you know is that something's getting damaged, but we don't even know what kind of landslide it is. You have to go figure out what the problem is. And so I think compared to some other engineers, right? Yeah, you just look up your manual, and that's as Paul said, that's not true, right? Every engineer is doing those things, but I do think geological engineers have kind of that mindset's a little bit closer of half of our work is just doing a subsurface investigation. It's not even solving the problem. It's just trying to figure out what in the world is even going on. And you have to use so many different techniques to try to figure that out. And you probably still don't know the full answer. So, yeah.
And there's a flip side to that coin too, in that, and I would say as geological engineers and as civil engineers, we probably suffer from this a little more. Engineers are problem solvers, and we're used to being resourceful and pulling in things. And so there's always the danger of stepping outside of your area of expertise. And I would say the ones that are most vulnerable to that are geologicals and civils, because by definition, we have these kind of interdisciplinary fields. And we can deal with soil, and we can deal with rock, and we understand how water works. And therefore we think we can do any problem that deals with those. And and I feel like some of the more narrowly defined engineering fields, it's a little easier to stay within your expertise and to define what the edges of that are. And so for ours, there's this danger that we could move outside of that, or not get the help that we need when we need it. We think we can do everything.
Yeah. I had another one, but Nina, if there are other folks in the queue, I don't want to.
Not that I know of, so go right ahead, Marie.
Great, thanks. So my other question was, I think this idea of competing interests as a tool to investigate all sorts of really complex negotiations is really interesting. So you gave an example of how you're working with students through competing interests. Can you talk about how you learned, or sites that you learned, that this is an important thing for engineers to learn? You've mentioned it kind of throughout your talk, but I wonder if competing interest is something you can expand upon, and sites that you could see it being moved into engineering at other places.
I'm sure there are books out there on engineering design and things that talk about them, and I've probably got a couple on my shelf that I've looked at, but I feel I learned that mostly from being in the consulting industry and doing consulting projects, and really trying to maintain my integrity and professionalism when I was feeling some push in another direction. I worked on an environmental site in Missouri that we were planning a really large groundwater investigation, because there were 5 Superfund sites in this town, and they were all blaming each other for the contamination. And you knew something was wrong with this company, because they were like, oh, well, look, we should investigate this, and we're worried about bedrock, and we're worried about what's coming in from offsite. And we're like, okay, yeah, but we got to manage what's coming in, what you're contributing to this. And then finally, at one point, they were digging and putting in a shallow utility, and they hit an abandoned trench that was filled with TCE again. It's always a problem. And suddenly the employees started remembering, oh yeah, we used to have this pipeline between these 2 TCE tanks, and at one point it was leaking for a while, and we lost a few thousand gallons of it, and then we eventually found it and repaired it, and nobody remembered that before. And this is like 1970s era mentality happening 30 years later. It's like, I thought we'd moved beyond trying to hide this stuff. And so I think just experiences like that, you're just always trying to be really careful. Most of the time, the client is not knowledgeably hiding things like this group was. But you know, I think we had gone into this saying, here's what you need to do. You've got to worry about your problem and problem that's coming from offsite.
Thanks.
Yeah. All right. So I want to be mindful of everyone's time as much as I would love to hear about all of your past endeavors or future research projects, Dr. Santi. It is 6:07, so I think we're gonna wrap up this interview. I want to say thank you again, Dr. Santi, for being here. It was a very fascinating interview, and I learned a lot. And there were a lot of good points made that I had never thought about. So yeah, I hope you guys all had a good time during the interview. And it will be posted. This recording will be posted on the HE Media News page. I can put the link in the chat. And if there's nothing else, you guys have a great night.
Thanks, everybody.
Everyone.
I had fun. I hope you did too.
This was great. Thank you very much.
Thank you.